All right, so here we go. Unit 8, Skill 9A. How do we adjust our equation when the rate changes every n times? That's going to be opposed to the changing every year or every month, on a monthly basis or yearly basis. It still could be those things, but typically when it happens every n times, it's something a little bit different. So let's jump right into a question. All right. So adjusting how a population changes, all right, when it happens every n times. So if it doubles, right, every, I don't know, this first question is 60 days, or if it's doubling every fourth year, all right, we typically take that t and we're going to divide it by n. Typically the t is some measure of time, and the n is also how long it takes for it to officially do that. So it's the same formula, except we're going to have t over n, where n is the how long it takes to do whatever it's doing. Happens every n times. So let's read the first question. Population of rabbits doubles every 60 days. The initial population is 10, given the formula that we have here, where p is the population of rabbits on day t. What is the value of t when the population is 320? So you can see in this first problem, it's very basic. We start off with an initial population of 10. So here we have that. Come on. So here is our 10, initial population. And then it says it's doubling. That's where the 2 comes into play. So the doubles is the 2. And then it says every 60 days. And that every 60 days is the happens every n times. So it's every 60 days, and that's why we're dividing by 60, where p is the population of rabbits on day t. So what is the value of t when the population is 320? And this is that whole question where you have to work backwards. So it says the population is 320. That is your final population. So we're going to go with A, which is P, which is 320. Come on. And that's going to equal the 10 times 2 to the t over 60 power. And now we have to work backwards and solve. So we'd like to get t alone. The first thing we have to do is divide by 10. That gives me 32 equals t to the 2 to the t over 60. Now we're going to do our log. Forget b to the e equals n, so it's base to exponent equals a number. All right. So we have log, base says the base, switch the other 2. So the base is the 2 here. So it's log base 2. All right, and it's got to equal. So it has to equal, that is the exponent. All right, so it equals the exponent, which is the t over 60. All right, so it's base to the exponent equals a number, so it's log base 2 of 32 equals the t over 60. Just basic log rules. Type that in your calculator. You get 5 equals t over 60. Now we go to the cross multiplication stage. All right, and you see something equals a fraction equals something. You know you're cross multiplying, so 5 times 60 and t times 1 gives me t equals 300. Okay? So if you look off to the side here, you can kind of see what's happening. And I do kind of want to explain that happens every n times. So take a look here. You see that every 60 days, right? 60, 120, 180, 240, and I intentionally skipped the 1 through 59, 61 through 119. But you can see that every 60 days, what's happening to the population of rabbits, the number of rabbits. And at day 60, it goes from 10 to 20. At day 120, it goes from 20 to 40. And so on and so forth. So every single time it's multiplying by 2, multiplying by 2, multiplying the previous value by 2 to come up with the next one. That's showing that it is in fact doubling. And that's because of that every 60 days we're dividing by 60. If this was divided by 30, you'd see 30, 60, 90, 120, and it'd be doubling then. Stop that. All right. Let's go on to the next question. So here we have it. An endangered species of birds is being monitored for population growth. Scientists have seen a growth rate of 6.35% every 5 years. That happens every n right there. Initial population, there we have it, is 120. So write a function that will give the population of birds for any year. So the population, so we're going to have A equals, all right. So A equals, and the initial population, all right, that we're going to have. Maybe we should write the formula A equals P 1 plus R to the T over N. So the P, the starting amount, it says is 120. All right, and then we have a growth rate of 6.35%, so that's 1 plus. Don't forget to change that to a decimal, 0.0635, to the t over n. T is what we don't know. We want to know it for any year. And it's t over, it says every 5 years, so it's going to be divided by 5. And there is your equation, okay? So the 120 again is your starting amount. Let's see if we can get the highlighter out. So the 120, that is your starting amount. That's what it said. The 6.35% is your rate. So there is your rate. And that happens every 5 years. And there we have it. All right, so it says, the next question, more than likely on the Regents, what you're going to see is during what year will the population of birds grow to more than 200? You're going to see that as the question. They're probably not going to ask you this question right here, question A. They're going to assume that you write this equation and then jump right to this. So just be aware that you may not see part A where it says write the equation first and then do part B. You're just going to see the whole question is one problem. So when will the populations grow to more than 200? So we got to plug in 200. So 200 is the final amount. So it would be 200 equals. Then we have our 120. Come on, start writing. 1.0635. Apparently I have to write ridiculously slow to get this to work, which doesn't help with my messiness. All right, so to solve this again, it's the same idea as it was the last time. You want to get t alone, so the first thing we're going to do is we're going to divide by 120 on both sides. I don't like to have to write the decimals. If it doesn't work out, you can leave it as a fraction. So I'm going to leave it as 5/3 is what it reduces to. All right, because that's 1 2/3 is a repeating decimal, and I want to be as precise as possible, so I'm not going to write that decimal yet. Copy everything over. Now we have the exponent is our variable, so we're going to use logs again, just like we did in the previous page. Base stays the base, so it's log of base 1.0635. And we're going to be raising that to the 5/3 power. I'm sorry, of 5/3, not raising it to the power. So it's log, the base of 1.0635 of 5/3 is going to equal the exponent. Because remember, a log is just an exponent. The log will always equal the exponent. So we solve that. Type in the calculator, push enter. It gives us 8.29729 equals t over 5. Notice I went quite a few decimal places. I'm going to cross multiply. That gives me t equals 41.48. So it says during which year, and this is the important part. It says during which year. Well, during means it happens during the 41st year, some point during that year. Okay? So we'd write 41. If it said by the beginning of what year, even though this is a 41.48, we would still say 42, because at the beginning of the 41st year, it didn't quite reach 200. And you can type it in the calculator if you want to see. Plug in 41 right here, hit enter. It won't be at 200 yet. It'll be close to it, probably 199, but it's not quite there. So if it says by the beginning of what year, you need to know that you are going to be rounding this bad boy up, and you got to think about that, or just plug the numbers in to check it. All right, don't forget, you have to do 8.9a and b, so watch the next video. All right, so 8.9b is half-life questions, and the essential question is how do we solve half-life problems? It is a specific style question that is directly related to the happens every n, okay, that we just did last class, where the rate is always going to be, you guessed it, a half, and that's it. So it's kind of nice. There's no 1 plus to worry about. It's just, hey, we're going to put a half inside the parentheses and go from there. All right, so titanium-44 is a radioactive isotope such that every 63 years its mass decreases by half. For a sample of titanium-44 with an initial mass of 100 grams, write a function that will give the mass of the sample remaining after any amount of time. Define your variables. So, all right, just got to start off with half-life of n. All right, so what's the half-life? It says every what? Happens every n right there. N is 63. 63, that is your half-life. All right, so we need to label P, A, T, and the rate. That's nice. All right, so what is P? P is that initial amount. So what is the initial amount in this particular problem? initial mass of 100, it says right there. So 100 grams is the initial. Okay, the A is your final amount. Okay, and that's what we're looking for. So a little question mark there. T, it says after, T is the time in years. And that's what we'll know in the problem. And then R is the rate, decay rate. And that is, it says it has a, where does it say it in here? Half, decreases by half. So it's 0.5 is the rate of decay. So when we write our formula, it's always the final amount equals the initial amount, right, P, which we see right up here, which is 100, times the rate, which is always going to be 0.5, okay, to the power T over N, which is every 63 years. All right, let's move on to the next page. So another problem similar to what we've been doing. An isotope has a half-life of 29 hours. For a sample of 250 grams of the isotope, write a function that would be used to determine the remaining mass after any amount of time.